Hi everyone, welcome to another video in my channel. As you know, India is trying to establish a very elaborate semiconductor mission in the country. In this regard, the government is bringing out many initiatives to establish the semiconductor value chain in the country. But then what is the semiconductor value chain which everybody talks about? And why is it so important, and what is its current state is something I wanted to talk about today. Of course, because this is a very happening topic, you might find a lot of resources, articles and even videos on this, but I just wanted to tell my personal views and idea of the ecosystem. To give a context, I now work for IMEC, which is considered the watering hole of the semiconductor industry. Kind of, on a day-to-day basis, I keep hearing about the different processes of the semiconductor manufacturing and what people are working on, what challenges they are facing, what is the new advancement they are working on, etc. But 10 years back, I used to work for NVIDIA as a design engineer. And what I was doing was mostly in system-on-chip verification, CPU verification. People in VLSI domain would know this. So I would write Verilog and system Verilog code to test different design elements of a chip. At that time I used to work on a Tegra mobile processor. And we would know that finally a big file called GDS file is created and it would be sent to some company and chips would come back. It was sent to Taiwan, it was sent to TSMC. But at that point of time, I was not really educated to know that this entire industry is such an important aspect of the chip market. We always thought, okay, I'm working in design, so it's kind of very fancy. But then the actual thing that was making it all possible was the semiconductor ecosystem, which I was absolutely blind to back in 2014, 10 years back. One reason for this is maybe that my engineering education never really handled any courses on the manufacturing process or the microfabrication process, you can call it, or the semiconductor manufacturing process. The entire course was focused on the theory and the design aspects of it, like analog design, digital design, how do you make circuits work, all those things, but how do you fabricate them? Indeed, we would know what a PN junction is, what a transistor is, but then really how do you make it from silicon? It was not taught. Fast forward 10 years, now I kind of understand the ecosystem. I have discussed with people, read about it, worked in the actual field. My PhD was related to microfabrication as applied to healthcare, etc. That now I understand and appreciate how global this value chain and this ecosystem is. To talk about it, as you know, as is told by many people, the semiconductors fundamentally come from sand. So most of the chips that we know are fabricated on silicon wafers, and the silicon wafers fundamentally come from sand, which is the silicon raw material. Now if you look at the whole design process of a chip, design and manufacturing process of a chip, as you call it, or an ASIC, or an ASIC application specific integrated circuit, which is made on silicon wafer, there are different players here. One set of players are the softwares that you need to make this design. Let's say you want to make a layout, you want to make transistors, connect them together, make different layers. So you have the tools or the software ecosystem, which is the EDA tools or the electronic design automation tools. That's one part of the design. Then that's where you create the design. Then when you look at the other side of it, which is the raw materials, you need silicon wafers to start off. You need chemicals such as photoresists, other specific reagents, different types of photoresists, and the cleaning agents, the developers. So many chemicals are there. Chemicals and consumables is one aspect of this value chain. Then you have the actual foundry or the fab, we call it, the fabrication facility, which houses this clean room facility so that minimum amount of contamination goes into the silicon wafer. So you have the fabs. So that is another part of the value chain. And then you have, after the chip is fabricated and you dice it out into individual elements from the wafer, you need to package it and then test it. So you have the assembly, test and packaging set of companies. Now these are all individual elements, right? But somebody needs to make the design using the design software. So that's where the design companies come in. Within this design company, there are two types of companies. There are fabless companies and the companies with fabs. So Nvidia, for example, is a fabless company. What does it mean by when it says it's a fabless company? That means it does not have its own fabrication facilities. It uses these EDA softwares and comes up with its own design, makes the design, does the simulations, does the emulation, all those things, makes a file that needs to be fabricated, or the design that needs to be fabricated. It goes to the foundry. The foundry then connects with all the consumable manufacturers, equipment, tools. So then another aspect of this value chain is the tool manufacturers. I'll come to that. It's the most interesting aspect of this whole value chain. Are the advanced tools that you need to make, the tools that do the extreme lithography that makes this advanced scaling possible. So that is handled by the foundry. So there are fabless semiconductor companies, and then there's fab companies with their own fabs, like Intel, Samsung, Micron. They have their own fabrication facilities to manufacture their chips. So now I said about the different topics or different verticals in this value chain. Currently, the way the world is right now, this value chain is distributed across the world. And there is considerable expertise in the Asia Pacific region, especially in the Southeast Asian market, to the extent that they have got a big upper hand in calling the shots. As many of you would know, the biggest fab foundry, semiconductor foundry in the world is located in Taiwan, which is the Taiwan Semiconductor Manufacturing Company, or the TSMC. And other companies are like companies like Global Foundries. Of course, Samsung, Intel have their own foundries. And then if you look at the consumables market, which is the wafers, the chemicals, photoresist, developers, etc. Again, you can see that there Taiwan, Japan, and of course a few American companies are there as players. Now you look at the equipment. So you basically take the wafer, use these chemicals, put them in some equipment, do lithography, photolithography process, which is the most critical process, apart from other fabrication processes like deposition, etching, dicing, etc., and get the chips. So for all these unit processes, you need equipment. One of the most important equipment is the lithography machine, and currently it is almost like a monopoly. The most advanced lithography machine is manufactured by just one company called ASML. So ASML is based out of Netherlands. So ASML supplies the most advanced lithography machines to the entire world. They are the most valuable semiconductor company that many people are not even aware of. Nvidia is now very much in the news because its market capitalization has crossed, I think, trillions of dollars now. But then there is also ASML, which is one of the most valued semiconductor companies for the semiconductor manufacturing process. So that is the equipment. So equipment, most players are, so you talk about ASML, which makes the lithography machine. Then you have Zeiss, which makes all these lenses. You have Applied Materials, which makes a lot of these other equipments for other unit processes. So there are some equipment manufacturers. And then the fabless semiconductor companies and the companies with fabs are distributed across the world. There are US companies, there is of course Samsung, there are some European companies. And then you have the chip that is made, and then you need to package it, right? Again, the packaging, test and assembly are also heavily captured by the Southeast Asian market. Now, this happened because of some historic trends, because of capitalism, because of profit maximization. Many of these aspects were outsourced to Southeast Asia, and over a period of time, they gained expertise in these nitty-gritties of when you do the actual process, you figure out some things, right? Like you need to do certain things in certain way, then it will work. That know-how is now rested with these manufacturing fabrication companies like TSMC. Now other countries are beginning to or trying to achieve self-reliance. In my opinion, it is very, very difficult and almost not a good idea to go towards complete self-reliance, because it's next to impossible. It's an enormous ecosystem. But all countries started thinking about self-reliance, especially during COVID and after COVID, when there is a huge semiconductor shortage. It's even a shortage of wafers, and because of lot of logistic restrictions that came into place, there was chip shortages, economies were affected. That's when countries realized that they need to be self-reliant as possible. That's also the reason why India started a semiconductor mission. One important observation here is, if you look at the different players in this ecosystem, you can see that I spoke about a lot of countries, but India was never there. Because sadly, we kind of missed the semiconductor bus. And after the first transistor was discovered, Texas Instruments and other companies heavily tried to integrate these electronics on chip, try to scale it up. But we did have the SCL semiconductor lab in India. We still do have, but the most advanced, keeping pace with the evolving industry, was something that we missed. It's a bus that we missed, and we are trying to catch up. And the Indian idea that is being evolved right now is also really nice, because we are also not trying to replicate what is there in the world. What we are trying to see, so you know that okay, silicon wafer is there. Many of these foundries make silicon devices on silicon wafers, but there is also a separate market which is on glass. Whatever displays that we see, the 4K displays on TVs, the 2K displays, all those displays are based on slightly different technology called thin film transistors, or TFT technology, which is made on glass substrate, not silicon substrate. So that is made by a separate set of foundries called FPD fabs, or flat panel display fabs. That is still a market that can be tapped and is not fully captured by other companies. So India is trying to set up unique expertise centers for such display fabs. So India, we are doing things to do that. So each country, even in Europe, there are countries who are trying to become self-reliant, but eventually what I feel is many of these countries realize that they cannot do everything by themselves. They do need to coexist within each other while also protecting their national interests. So that's where everything is going to stabilize. Still, many of these things would be controlled by other countries, because that becomes their expertise over the years. Eventually, India also should try to attain some expertise in some aspects of it. But sad part is that we need to run much faster. We have a lot of things to catch up, because we kind of missed the bus. It is almost like what happened historically is like we were focused. If you look at sports, we were too much focused on cricket that we kind of stopped focusing on, even as fans, we stopped focusing on other sports, and that's the reason why we never used to perform very well in Olympics. Same way, when the world was also focusing on the semiconductor value chain, we were actually very much involved in the IT boom in the country. We became literally the IT superpower in the world, but at the cost of missing out on the semiconductor race. But yeah, things are changing, and I think we might be able to put our name in at least some of the elements of this value chain. But to summarize, it's a very complex economically driven semiconductor value chain that historically has come into place. There are strong players in the Southeast Asian market, and most of the design aspects are centered around Europe and America. And right now in the value system, India doesn't have much role to play. Although again, most of the brilliant designers, many of the brilliant designers are either in India or of Indian origin. They are contributing to humanity. If you leave all these boundaries of nation states and national interests aside, as we as Indians are contributing to the advancement of humanity by improving our computing capabilities, improving our scientific capabilities, because these chips go everywhere. You know, you have the AI boom, you have the machine learning boom, but even if you look at searching for life outside the planet, you need high computation, you need to constantly process large amounts of data. For all this you need semiconductors, for all that you need computing power, and the computing fundamentally comes down to chips. So if you look at it from a human endeavors perspective, everybody is contributing to this ecosystem. and I just wanted to tell you how advanced and how complex this ecosystem is. And earlier, being engineering students, the earlier we acknowledge the importance of manufacturing and manufacturing the right way and give due credit to it, we won't understand the challenges that the industry faces. Design is good, but equally important and interesting is manufacturing as well, be it microfabrication or macrofabrication. On this note, I'll say bye bye.